Alright, so homework 4, question 4. The first thing we notice is that this set P has 8 elements. And we're interested in the subsets that have 5 elements. So how many of those include 4? Well, let's start by writing them out. So 4 has to be an element. And if we have interested in the subsets with 5 elements, then there's going to be 4 empty spaces. So we've already got 4, and so we'll have 7 elements, and we need to choose 4. And so that's the calculation we need to perform to get our answer, and the answer should be 35. You can check that at home. Also, do not include 4. Well, here we need 5 elements, but we are not including 4. So what that means is we'll have, how many will we have left to choose from? Well, we'll have 7 to choose from, because 4 is no longer in the set. And we're going to need to fill the 5 places for the 5 elements. So in this case, the answer will be 28. Okay, so in part C, we want to include E and 11. So when we draw our set, E and 11 must be included, and we have 3 remaining spots that we can choose from the elements that are left. So which elements are left? Well, if we, let's just erase that. If we take out E and 11, then you can see that we've got 6 elements that we can select from, and we need to choose 3. So that's the calculation. If you work it out, we'll get 20. That's 20. Okay. In part D, we notice that this is slightly different from part C because we're interested in the ones that do not include E and 11. So it's the same kind of thing as here. It's just that this time we want the ones that do not include. Well, so if we worked out the total and subtracted our answer for the ones that did have it, that's in part C, then we'd work it out. So what's the total number of subsets with 5 elements we could have? Well, we know the total number of elements was 8, and we're going to choose 5. And in C, we remember that our answer was 20. So if we work this out, 8C5 actually happens to be 56. And so if we do that simple subtraction, we'll get our answer of 36. So part E is a little bit different. We can see now that we want to do not include E or 11. Now it's useful if we consider looking at this example here back at C. We're going to use the same idea so we can sort of discount the E and the 11, but the calculation changes significantly. So the difference here is that we still are going to, when we discount E, do not include E or 11, then there's only 6 elements we can choose from. Let's go back to our working out colour. So there's 6 elements possible here when we discount 2 of them. But in this case, in part C, we had 3 elements to choose from because these 2 positions were locked in. But we do not have the locked in positions here now, so we still have to pick 5 elements to make up our set. Remember, it's with 5 elements. So that's the difference here when we don't consider the E and the 11 there. So this answer gives us 6. That calculation gives us 6. All right, so now we want to include E and 11. So that's, again, similar to C, E and 11, but this time not A. So that means that A cannot be considered. We must have E and 11. But in our 3 remaining spots here in our set of 5 elements, we can't choose A, so that means we've only got 5 to choose from now. So you can see the difference in the calculations here for C and F. And the answer for this is 10. Alright, so for question 5, last one for this homework, we're asked to explain why that big expression is true. Well, what we should notice here is that this left-hand side is the sum of the nth row of Pascal's triangle. And you should be able to see that if you put in any number there for n. And on the right-hand side, well, this formula looks, that's a formula we've learnt in class. It's the total number of subsets. So how do these two things relate? Well, This term here tells us the number of subsets with 0 elements, if we have n elements. And this tells us the number of subsets with 1, 2 element, n minus 1 element, and n elements. So to link these two together, it's the sum of the number of subsets by the number of elements that are in each subset. So this gives us this, and that in turn, if we add all of them up, it gives us the total number of subsets. So what we can say is that these two things are indeed equal.